The fourth article in the series about SRE Concepts is about two topics: root cause analysis and error budget. Root cause analysis. Why is it important? What do you do when a product exhibits a defect? You don't just go out and buy another one, do you? You first take the product, disassemble it, and check every part if it's working or not. In other terms, you look for the primary cause of the issue. Well, that is root cause analysis. It is a methodology used to identify the cause of a defect or an issue. Root cause analysis is done in almost all the fields that involve a product that can fail. Since any product can fail at any given time, we use it pretty much everywhere. Root cause analysis in the IT sector works the same way. When you identify an issue, you get to the bottom of it and determine the cause of the problem. A root cause analysis can give us a lot of info on the weak points in our development lifecycle, points of recurring defects, and much more. It is essential to perform a root cause analysis after every failure, even in test environments. How does root cause analysis help reduce defects? A root cause analysis requires every issue to be documented and logged. Once a defect is noted down, a team proceeds to resolve that defect. So, let us say that there is a recurring defect at point A in a development lifecycle. We plot a Pareto graph to study the total defects and the frequencies at which we encountered them. The higher the frequency, the more recurring the weakness is. This way, we can identify and resolve a recurring defect, reducing the overall number of defects in an application. Advantages of root cause analysis. A root cause analysis's primary advantage is that it finds the most essential product development lifecycle errors. This advantage helps us identify silly mistakes and correct them before deploying them for the customers. Since a root cause analysis can be executed during the development lifecycle, at that moment the cost to fix the errors won't be that bad. If these errors made it into the production lifecycle or the release cycle, they could cause a lot of damage to the overall product. The worst case is that the defects are never corrected and made straight to the customers. Root cause analysis is also a critical safety measure in many industries. For instance, companies operating in healthcare and financial industries can behoove a lot from the root cause analysis because they can find the defects beforehand. If we do not perform the root cause analysis during the initial stages, they may be exploited in the future, causing millions of dollars of fines. Conclusion on RCA. Root cause analysis is the crown jewel of defect detection and repair. Always remember to do a root cause analysis in every step of your life cycle. Error budget. What is it, and how does it work? If you've been in the IT field for a while, then you may know that incidents always happen. Even though taking appropriate actions can prevent some incidents, you should be prepared to face even the most uncommon incident. Even services like Google and IBM have a downtime, however small it may be. Availability incidents cost companies millions of dollars every year. If a service level agreement promises a 100% uptime, likely the agreement is not drafted correctly. We may see a complete uptime in the future, but it is almost impossible with our technologies. Usually, you set realistic goals for your product's uptime. If you considered many cases and are prepared to take on any incident, then the uptime may be a bit higher than what you promised. For instance, you may have promised your clients an uptime of 99%, but reached 99.6% by the end of the year. However, you cannot change the agreement to promise this new uptime because you cannot know for sure whether you can handle the same incident in a better way the next time. Instead, this extra uptime is called an error budget. In simple terms, an error budget is the maximum amount of time a product can fail without facing any contractual issues. For instance, if you promised a 99.99% uptime in a year, the error budget will be 52 minutes and 35 seconds. It means that your product can fail for just 52 minutes and 35 seconds in a whole year. This error budget is usually calculated by using the time-based availability formula. The error budget increases drastically with a decrease in contractual uptime. For instance, if your promised uptime is 99.95%, the error budget is 4.22 hours and 48 seconds. If we reduce it further to 99.9%, your error budget will be a whopping 8 hours and 46 minutes. Generally, organizations consider all the incidents and present an uptime that both the SREs and other members are comfortable with. If you cross the error budget, you might have to follow the protocols you agreed to when signing the agreement. Why do we need error budgets? Error budgets are not an abstract metric for site reliability engineers. They hold a lot of significance for a product. For instance, if you plan on launching a new feature and have to put the application under maintenance, you have to borrow some time from the error budget. Not just this, you can use error budgets in any way you see fit. As a site reliability engineer, you have to monitor the error budget closely. If you cross the error budget or may cross it soon, you may have to freeze the launch of many features to prevent any downtime. You can only take a risk if the uptime is more than what the contract requires. Conclusion on error budget. Error budgets are a vital metric that every site reliability engineer must know. Understanding the error budget and using it innovatively may give you an edge over your competitors.